Talk? Is that what you said? Oh, okay. Oh, don't call on you. Okay. Oh, that's right. I don't have my little thing set. All right. Here's what we're gonna do. We're gonna do two sections: 6.2, 6.3. They're all about inequalities and solving inequalities using multi-step and inverse operations. So I'm gonna begin by doing a little experiment. Okay. Do you agree that 3 is bigger than 2? Is that true? Is 3 bigger than 2?
Yeah.
Yes. Everyone, yes, we all agree 3 is bigger than 2. Okay. Now, I'm going to multiply this number. I'm going to multiply each side by a positive number. So can someone out there give me a nice, easy positive number? Yes, sir. 5. Good. Let's take 3, and we're going to multiply both sides by 5. 2, multiply both sides by 5. And I want you to predict what you think the inequality sign is going to be. Is it still going to be the same as before? Is it still going to be greater than? What do you think?
Yeah. It's going to be the same because isn't the multiply together or additive property of...
Yeah, but this is similar. This is similar to the additive property where we're doing something to both sides, but in this case we're not adding, we're multiplying, right? So I'm leading into something. Okay, so how many agree that this is going to stay the same, like that? Yeah, most people have their hands up. Yeah, and in fact this is true, right? 15 is definitely greater than 10. You guys agree with that part so far? Okay, good. But now let's do another experiment. Okay, I'm gonna start with the same thing. 3 is greater than 2. We all agree that 3 is greater than 2. Now, someone give me a negative number. Give me any negative number out there that we could easily use. Yes, sir. Negative 5. Okay, I like where his head's at. 3 times, we're going to multiply both sides by a negative 5 here. 2 times a negative 5. Now, I want you to predict. Should that inequality sign stay the same? Okay, y'all say no. Let's investigate here. Let's assume I didn't know anything. Let's just say, oh, yeah, it must be the same. So this says negative 15 is greater than negative 10. But is that true? No, that's not true. Don't get confused. Just because there's a 15 and a 10 on the page, don't get confused and say, oh, it must be one or the other. It must be this way because remember, here's 0, here is negative 10, and here is negative 15. So how do you know which one's bigger when you're in the negative territory? Yes, Sasha, what do you think, buddy? Which one's closer to 0, right? This one, 10 is closer to 0 than 15. That means that 10 is actually bigger. 10 is bigger. Does that make sense? So, what in this case, in order to make this statement true, we have to take this inequality and we have to reverse the direction of the inequality to say that negative 15 is now less than negative 10. So the trick is, or what we've seen here, is if we're going to multiply by a negative number, we need to reverse the direction of the inequality sign. And that's basically everything that the multiplication property is telling us. So let's write that part down. So the multiplication properties of inequalities. So in section 6.1, we talked about the addition and subtraction properties of inequalities. Now we're talking about the multiplication properties of inequalities. And just like before, there's 4 of them. 1, 2, 3, and 4. So we're going to list them all out, make sure we understand. And they're all if-then statements. So if we say A is less than B, and we're going to take another number, C is greater than 0. So C is a positive number. So if A is less than B and C is bigger than 0, so a positive number, then we are safe. We're going to say that A times C is still less than B times C. And we saw that example right up here. That's an example of this. We did not need to change the inequality sign. However, if your number A is less than B and C is less than 0, which means that C is negative, then when we multiply A times C, we reverse the direction to make it greater than B times C. And we saw that example right here. That's an example of this one. How we had to reverse the inequality sign because negative 10 is not bigger than, or sorry, negative 15 is not bigger than negative 10. Is this making sense, you guys? Yeah? Okay, good. So these two kind of go together, right? These two go together here. All right? And then, of course, we can say, right, well, if A is greater than B and C is greater than 0, then we're in safe territory. We know that A times C will still be greater than B times C. That's still safe. So these two kind of go together here. But if your A is bigger than B, but C is less than 0, well, again, we have to make sure we reverse the direction of the inequality sign. That'll say that A times C is now less than B times C. So the top two in yellow are the less than features, and then the bottom two in the blue are the greater than features. And it also works if it's less than or equal to underneath the same box here. Okay? We're going to use some examples of the multiplication property of inequality. We're going to talk about this one. We're going to solve and graph. No, this correlates to the multiplication. So we're going to solve and graph this one. We're going to take m divided by -2 is less than 5. We're going to solve and graph this one. M divided by -2 is less than 5. All right, what is the inverse of multiplication? What's the inverse of division? What's the inverse of addition? What's the inverse of subtraction? Okay, now in this case, we're taking m divided by a -2. If I want to isolate the m, how do I invert a division? I multiply by what? By 2? I multiply by -2, both sides. I multiply by -2. That way I can see here that my -2's divided by -2's make a 1. And that leaves me with m, an inequality sign, and then I have a -10. Now, what did we just do? Did we multiply by a negative number? We did. If we multiply by a negative number, we must do what? We must reverse the direction of the inequality sign to give us m is then greater than -10. And if I'm going to graph this on the number line, I told you that I need 2 points. I need 0, and where's -10 have to be? To the right or to the left of 0? To the left. Very good. Do I put an open dot or a closed dot? How do you know it's an open dot? Because it's not greater than or equal to. And we shade to the right. So any one of those answers, that's as long as it's bigger than or bigger than 10, it will make the original statement true. Right? It will make the original statement true. So give me a number that's bigger than 10. We're going to check right here. 12. Or 56. Good. Any one of those. So let's see here. Let's take 12. Let's divide it by -2. Is that still less than 5? Is -6 still less than 5? Is that true or false? That is true. Any number that's in that category that's greater than -10 will make the original statement true. Is this making sense so far? Yeah? You guys feel good about it? Yeah? I'm gonna say, start off with an example. I'm going to start off with an example here. You guys all agree that that 10 is definitely greater than 6. Is that true? Is 10 bigger than 6? Okay, good. Now, all right, someone give me a positive number. Give me a positive number out there that we can easily divide by. Yes, sir? 2. Good. I like that idea. We're going to divide both sides by 2. Okay? So 10 was bigger than 6. If I divide both sides by 2, what is 10 divided by 2?
5.
Is 5 bigger than 3? Is that true or false? That is definitely true. Okay? However, we saw this one to be true. However, what would happen if I said, okay, let's start with 10 is bigger than 6, but I divide both of these by a -2. If I change that to a -2. Is it still true that -5 is bigger than -3? No. So what do we have to do? You got to flip it. -5 would be less than -3. That would make that one true. So is there a similarity, everybody, between the division property and the multiplication property? Yes, there is a similarity here with the multiplication property and a similarity here with the division property. What do you think that similarity is? Yes, sir. Sasha, what do you think, buddy?
Now when you multiply by negative or divide by negative, you're going to have to flip the signs because the greater negative is less than the less than.
That's beautiful. If everyone didn't hear him, he said this. He said when you multiply or divide by a negative, you have to reverse the direction of the inequality sign, because otherwise it won't make the original statement true. So you can imagine what these are going to be, right? This is going to say, all right, if A is less than B and C is bigger than 0, still positive, then we know that A over C is still going to be less than B over C. That's okay. That was the first example. But if A is less than B and C is negative, then A over C is going to be bigger than B over C. And that was that second example that we saw. And you can imagine what these ones are going to be. All right? If A is greater than B and C is greater than 0, so C is positive, well, then we're good. A over C is still greater than B over C. However, we've learned now that if A is bigger than B, but C is less than 0, just like Sasha said, we need to reverse the direction of the inequality signs. So A over B will be less than B over C. Sorry, that should be a C. Morgan? Okay, here we go. We're going to do some examples together to illustrate all the properties that we've learned so far. We're going to solve and graph. So we're going to do these together. Here we go. Number 1. We're going to solve a negative 4x is less than 36. Negative 4x is less than 36. All right. Which one's the variable? Someone tell me what the variable is. X. Okay, what is being done to x right now? Am I adding negative 4 to x? Am I dividing negative 4 to x? What am I doing? I'm multiplying, right? What's the inverse operation of multiplying? Dividing. We're going to divide by what? Negative 4. Uh-oh. If I am dividing by a negative 4, what do I need to do? Flip the direction of the inequality sign. So I should have this for an answer. X would now be greater than how much? Negative 9. Yes. Now, how do I graph that on the number line? Here's 0. Where does negative 9 go? Negative 9. Open dot or closed dot? Open. And which direction? To the right or left? To the right. You got it. Okay, what do you guys think? Easy, medium, or hard for this one? Easy, medium, or hard? Easy? All right. Easy? All right. All right. All right. I'm with you. I'm with you. Okay. Oh, you think so, huh? Okay. Let's do this one. How about 4x plus 6 is greater than 54? Oh, now same directions we're going to solve and graph. This is a little bit different, isn't it? There's a couple of things we need to do, right? First, identify the variable. Where's the variable? X, good. Okay, now, from x, am I multiplying 4, adding 4, dividing 4, subtract? I'm multiplying 4, and then I'm adding how much? 6. So I need to undo everything on the left-hand side. So what would be my very first step? My very first step? Subtract 6. You got it. You got it. We're going to subtract 6 from both sides. That gives me this. 4x is now greater than, what's 54 minus 6? 48. Now, did I need to reverse the direction of the inequality sign? No, because I did not do what? I did not multiply or divide by a negative number. Okay, now I'm going to divide by what? Divide by 4. Am I dividing by a positive or a negative number? Positive. Do I need to reverse the direction of the sign? No, I don't. Very good. So therefore, x must be greater than how much? What is the something? 12. Very good. Okay, if I'm going to graph, if this is 0, where's 12 need to be? To the right. Very good. Give me an open dot or a closed dot? Open, and we shade to the... Very good. You guys catching on to this? No, we're going to do one more together, then the last box is going to be on your own. You guys ready for a more challenging problem? Okay, here you go. Negative 1/3 times x plus 21 is less than 2. Nope, no, we're doing this one together. Okay, first, identify the variable. Here's the variable. The variable is x. We are then adding 21 to x, and then we're multiplying that whole number by negative 1/3, right? You guys see it? So, here's the trick. We're going to clear these fractions here. I'm going to multiply by the opposite reciprocal. What would that be? Yeah, I'm going to multiply by, oh, sorry, not opposite reciprocal, just the reciprocal. Negative 3 over 1, right? Negative 3 over 1. Did I multiply by a negative number? Yes, I did. That means I need to reverse the direction of the inequality sign. Greater than, notice I reversed the direction, negative 6. Because 2 times negative 3 is negative 6. Does everybody see that I reversed the direction of the inequality sign right there? And why did I do that? Why did I do it? Because I multiplied by what? By a negative number. All right. Next step. What's my next step to isolate x? Yes. Subtract 21. Therefore, I end up saying, okay, x must be greater than negative 27, ladies and gentlemen. Negative 27. So if I graph, here's 0. Where does negative 27 go? On the left. Very good. Do I go open dot or closed dot? And right or left? There. Okay, last box is going to be a you try. I want you to think about this particular problem all on your own. You're trying to solve for x. It says negative 2 times 3x minus 1 less than 1 minus 6x. Okay, here we go. Let's talk about this. All right. So it's been about 3 or 4 minutes, and you've been working on this particular problem. It says negative 2 times 3x minus 1 is less than 1 minus 6x. Okay? Now, I want to show you a few things. First of all, take a look at the graph that I just generated from this particular problem here. It says 3x is greater than 9. Do you see the graph over there? Do you guys see the graph? Yeah. And what does it look like to you? What's going on over there? No. On this particular graph right here, what does it look like? How do you describe what you see? Yeah, Kyle.
Everything on 3 and to the right of it seems to be highlighted and marked.
Yeah, he's saying everything from the 3 to the right seems to be highlighted and marked. Do you know why that is? Why is that? What do you think? Yeah, if I were going to solve this, right, if I had 3x is greater than 9, if I was going to solve this, I would divide by 3, correct? And I'd find that x is greater than 3. Does this represent 3 right here, the line x equals 3? And notice that the line is dashed. What does that mean?
It means it's not equal.
It means it's not part of the solution, right? But everything is graphed to the right of it. Have a seat. Thank you. All right, so now, if I was to do the same thing with this particular graph here, this is the one that we just were talking about, right? So let's see, if I were to take this information here and try and put this on the graph, let's see if it can actually graph something for me. We can get an answer here, all right? Anybody see anything on this particular graph that looks interesting to you? No? What do you think, Sasha?
I see a lot of lines.
You see a lot of lines, right? But do you see anything that looks like that? No. How come? Because there's no solution? What do you mean there's no solution?
Because if you do everything right, you have to subtract 3x from both sides.
It says if you do everything right,
It's like 3x is less than 1.5 plus 2x.
well, how many of you did this? How many of you distributed first? There you go. Negative 6x. What's a negative 2 times negative 1? Plus 2 is less than 1 minus 6x. Then what should I do? Add 6x to both sides. Add 6x to both sides. So that says 2 is less than 1 minus 0. 2 is less than 1. Just repeat that sentence a few times in your head. Is 2 less than 1?
Yes.
No, 2 is not less than 1. This is false. Therefore, that means that there is no solution. And that makes sense why there's no graph that can correspond.